Look up. Beyond the city lights, the universe unfolds, an endless sea of stars, swirling galaxies, and distant worlds. What mysteries await us out there? Why are we here on this tiny blue planet adrift in the cosmic dark? Join me on a journey through space and time. Together, we'll explore the wonders of the cosmos, discover our place in the universe, and witness the breathtaking beauty of creation itself. The adventure begins now. The universe is calling. Will you answer? Imagine yourself floating free, unbound by gravity, as the ship of the imagination lifts you above the world you know. The city lights fade behind, replaced by the deep velvet of night. Stars begin to multiply, each one a distant sun, each one a mystery waiting to be explored. Our planet becomes a fragile island in an infinite sea. We drift farther, and the scale of the universe begins to reveal itself. The moon glides by its scarred surface, a silent witness. Planets line up like glowing jewels on a velvet string. The sun bathes them all in golden light. The true tapestry of the cosmos emerges. The Milky Way arches above us, a river of stars stretching from horizon to horizon. Each pinpoint of light is a world unto itself, and the distances between them are vast beyond comprehension. We pass through clouds of interstellar dust remnants of ancient stars, the raw materials for new worlds and new beginnings. Nebulae bloom like cosmic flowers, their colors and shapes sculpted by titanic forces. We see the immensity of the unknown and the delicate beauty of existence. The universe is not empty. It is alive with motion, transformation, and wonder. Every atom in our bodies was forged in the heart of a star billions of years before our sun was born. We are connected to the cosmos, made of its dust, shaped by its laws. As we journey outward, carry humility and curiosity. The universe calls us, not just to explore, but to understand, to seek our place among the stars and to marvel at the story written in the light of distant suns. Our adventure has only just begun. Our journey begins here, on our homeworld, planet Earth, a sphere of brilliant blue, vibrant white, and living green, adrift in the silent, star-dusted expanse of the cosmos. It is, as far as we know, the only world of its kind, a precious and singular outpost of life. From the vantage point of our ship of the imagination, let's pull back and see it as a whole, a masterpiece of cosmic chance and physical law. Look closer. See the thin, almost invisible layer that hugs the surface? That is our atmosphere, a multi-layered ocean of air. Composed primarily of nitrogen and life-giving oxygen, it's structured in layers. From the troposphere, where our weather happens, to the stratosphere, home of the vital ozone layer that absorbs the sun's most harmful ultraviolet rays. It is a fragile shield of gas that protects us from the harshness of space, burning up most meteoroids before they can reach the ground and deflecting a constant stream of charged particles from the sun. It gives us air to breathe, water to drink through the hydrologic cycle, and moderates the temperature, preventing the extreme swings from scorching heat to freezing cold that we see on other worlds. This delicate membrane is what makes our world a living, breathing planet, a haven in the cosmic void. It is a testament to the perfect, rare balance of conditions needed for life to thrive. We orbit our star, the sun, at just the right distance, not too hot, not too cold, in a region astronomers call the habitable zone or the Goldilocks zone. This perfect positioning allows for the most crucial ingredient for life as we know it: liquid water. From this distance, you cannot see the borders that divide us. You cannot see the cities, the farms, the individual triumphs and tragedies. You cannot see the conflicts. You just see one unified planet, a shimmering sphere of life. The lights of our civilization trace the continents like a vast, interconnected nervous system, a testament to a single global species. As we pull farther away, Earth shrinks. The astronomer Carl Sagan, seeing an image like this from the Voyager 1 spacecraft, called it a pale blue dot, a lonely speck in the great enveloping cosmic dark. On it, he said, "Everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." Seeing our world this way inspires a sense of humility and unity. It underscores our responsibility to deal more kindly with one another, and to preserve and cherish the only home we've ever known. It reminds us that we are all passengers on this one small spaceship, traveling together through the universe. Before we venture out into the great unknown, let us take one last look at our home, engraving its beauty in our minds. This tiny, fragile world is our point of origin, our frame of reference for everything we are about to see. Now let's bring our ship of the imagination closer, diving through the clouds to witness the wonders of our planet's surface. The sheer variety is staggering, a product of billions of years of geological and biological evolution. We can soar over towering mountain ranges, their jagged peaks scraping the sky, built by the slow, immense collision of tectonic plates. We can glide over vast, scorching deserts, where life clings to existence in the most extreme conditions, and sand dunes ripple like a golden ocean. We can drift over the planet's frozen poles, the cryosphere, where colossal sheets of ice lock away ancient climate records and regulate global temperatures. Let's dive beneath the waves into the planet's blue heart, which covers more than 2/3 of its surface. Here, sunlight fades and a hidden kingdom reveals itself. We can see vibrant coral reefs, the bustling cities of the sea, teeming with life of every imaginable color and shape. Deeper still, in the crushing darkness of the abyss, where the pressure is 1,000 times greater than at the surface, we find life forms that defy imagination. Strange bioluminescent creatures light up the gloom, thriving on chemical energy from volcanic vents on the ocean floor, a powerful reminder that life can find a way in the most unlikely of places. Our planet is also a world of motion, constantly reshaping itself. The very ground beneath us is not solid, but a mosaic of shifting plates. We can follow the great rivers as they carve canyons through solid rock over millennia. Watch the dramatic, violent spectacle of a volcano erupting, creating new land. Witness the silent, powerful crawl of glaciers grinding valleys through mountains. From the gentle rustle of leaves in a forest to the thunderous, swirling roar of a hurricane, a colossal heat engine born over warm, tropical waters. This incredible diversity of environments has given rise to an equally incredible diversity of life, all connected in a complex web of interdependence. From the smallest microbe to the largest whale, every organism plays a role. Life has conquered the land, the sea, and the air, adapting and evolving to fill every possible niche. This is what life looks like. This is what a living world is. Understanding the richness and resilience of our own world is the first step to appreciating the potential for life elsewhere in the cosmos and the specific conditions it might require. With our home now a distant blue jewel, we turn our ship of the imagination toward the center. We are heading for the undisputed king of our solar system, the source of all its light and warmth, the sun. It is a star, our star, a perfectly average middle-aged yellow dwarf, yet to us it is everything. Its immense gravity holds the entire solar system in its grip. It contains more than 99.8% of all the mass in the entire solar system. All the planets, moons, asteroids, and comets are just leftover debris from its formation. Its surface is a roiling, turbulent sea of plasma. We see great arcs of plasma called solar prominences looping hundreds of thousands of kilometers into space. We see dark cooler patches known as sunspots, areas of intense magnetic activity. Sometimes the sun erupts in a solar flare, releasing a torrent of energy and particles, the solar wind, that streams across the solar system. Deep in its core, the pressure is 250 billion times that of Earth's atmosphere, and the temperature reaches 15 million degrees Celsius. The conditions are so extreme that hydrogen atoms, the most basic element in the universe, are fused together to create helium. This process is called nuclear fusion. This fusion releases a tremendous amount of energy. Every second it converts about 4 million tons of its mass directly into energy, following Einstein's famous equation, E equals mc squared. The light from this reaction can take over 100,000 years to journey from the core to the surface, and then a mere 8 minutes to cross space and warm our faces on Earth. But our star will not burn forever. In about 5 billion years, it will run out of hydrogen fuel in its core. It will then swell into a red giant, 100 times its current size, engulfing the inner planets, including Mercury and Venus, and boiling away Earth's oceans. After that, it will shed its outer layers to form a beautiful planetary nebula, and the core will shrink down to become a white dwarf, a hot, dense ember that will slowly fade over trillions of years. Leaving the sun, we journey to the first of the planets. This is Mercury, the swiftest planet, completing its orbit in just 88 Earth days. It is a world of extremes, with no real atmosphere to distribute heat. Its sun-facing side scorches at over 400 degrees Celsius, while its night side plummets to -180. Its surface is scarred with countless craters, a record of eons of bombardment. Yet in craters at its poles that are permanently shadowed from the sun, we find frozen water ice. Next, we glide outwards to Venus, a world nearly the same size as Earth, once perhaps our twin. Shrouded in a beautiful veil of white clouds, it reflects sunlight brilliantly. But as our ship of the imagination descends through its thick clouds of carbon dioxide and sulfuric acid, a hellish landscape is revealed. A runaway greenhouse effect has made Venus the hottest planet in the solar system, with surface temperatures high enough to melt lead. The atmospheric pressure is over 90 times that of Earth's, equivalent to being a kilometer deep in our ocean. We skip past our own beautiful Earth and set our course for the fourth planet from the sun. Mars, the red planet. Its rusty color comes from iron oxide in its soil. We see towering volcanoes like Olympus Mons, the largest in the solar system, 3 times the height of Mount Everest. And we see a vast canyon system, Valles Marineris, that would stretch all the way across the United States. Yet we see evidence that it was once a very different place. We can see vast, dried-up riverbeds, deltas, and lake beds. It seems that long ago, billions of years in the past, a thicker atmosphere allowed liquid water to flow freely on Mars. The great question is, if there was water, could there have been life? Today, a fleet of robotic explorers are our eyes and ears on the Martian surface. Rovers like Curiosity and Perseverance are acting as robotic geologists. They are searching for clues to its watery past, and for any signs of ancient microbial life preserved in the rocks. Leaving the rocky inner worlds behind, we cross a vast expanse known as the asteroid belt. This is not the crowded demolition derby of science fiction, but a vast, empty space populated by millions of rocky bodies. These are the leftover building blocks of planets that never formed, held in place by the immense gravity of our next destination. Among them is Ceres, a dwarf planet, and the largest object in the belt. We have arrived at Jupiter, the king of the planets, a gas giant so large that all the other planets in our solar system could fit inside it. Its atmosphere is a swirling masterpiece of colorful cloud bands and violent storms. The most famous of these is the Great Red Spot, a hurricane wider than the Earth that has been raging for centuries. Jupiter is also a miniature solar system of its own, with nearly 80 moons. Its 4 largest, the Galilean moons, are each a unique world. Our journey continues outwards to the 6th planet, the jewel of the solar system, Saturn. Another gas giant, slightly smaller than Jupiter, but no less majestic. What makes Saturn truly spectacular is its magnificent system of rings. They stretch for hundreds of thousands of kilometers, but are, in places, only a few tens of meters thick. They are made of countless particles of ice and rock, from dust grains to mountain-sized chunks. Saturn also has fascinating moons like hazy Titan, with its thick atmosphere and lakes of liquid methane, and icy Enceladus, which spews water vapor into space from a subsurface ocean. Beyond Saturn lie the final 2 planets, the ice giants. First is Uranus, a strange world that is tilted on its side, likely due to a colossal impact in its distant past. It rolls through space like a ball, with its faint rings and moons orbiting vertically. Finally, we reach the distant and mysterious Neptune, a world of deep, brilliant blue. It is the windiest planet in the solar system, with supersonic winds whipping its methane clouds into storms like the Great Dark Spot. Its largest moon, Triton, orbits backwards and spews nitrogen frost from ice volcanoes, making it one of the coldest known objects in our solar system. Our ship of the imagination has reached the edge of our solar system. The sun is now just the brightest of countless stars. Before us lies a new and even greater ocean of space, the vast emptiness between the stars. We have sent messengers into this new realm. The Voyager 1 and Voyager 2 probes, carrying a golden record. A time capsule of our world, a message in a bottle into the cosmic ocean. The nearest star to our sun, Proxima Centauri, is over 4 light-years away. But in our ship of the imagination, we cross it in an instant. Let's guide our ship into one of these magnificent clouds, a stellar nursery. From up close, it is a breathtaking spectacle of chaotic beauty. Stars are born from the slow, patient collapse of these giant molecular clouds. Gravity is the sculptor. A small, dense clump begins to form. It starts to glow with heat, a protostar. Finally, a critical point is reached. Nuclear fusion ignites. A star is born. A single nebula can give birth to hundreds or even thousands of stars at once. The Pleiades, or the Seven Sisters, is a famous example of a young star cluster. Not all stars are like our Sun. Some stars are much smaller and cooler than our Sun. These are red dwarfs. Other stars are giants. Blue giants are incredibly hot and massive. A star like our Sun will shed its outer layers, creating a beautiful glowing shell of gas called a planetary nebula. It collapses into a very small, incredibly dense object called a white dwarf. But for the most massive stars, the end is far more spectacular and violent. This collapse triggers a gigantic explosion called a supernova. The explosion blasts the star's outer layers into space, enriching the galaxy with heavy elements, the very building blocks of future worlds. The collapsed core becomes a super-dense neutron star, or, if massive enough, a black hole, where gravity is so strong, nothing, not even light, can escape. Let's pull our ship of the imagination way back to see our home in its entirety. For millennia, it was a milky band of light in the night sky. Now we see its true form. This is our home galaxy, the Milky Way, a vast barred spiral city of stars. The scale is almost impossible to comprehend, about 100,000 light-years across. It contains between 100 and 400 billion stars. That's more stars in our galaxy alone than there are grains of sand on all the beaches of planet Earth. Let's fly towards the galactic center, a dazzling and chaotic region. At the very heart, hidden behind thick gas and dust, lies a monster, a supermassive black hole, Sagittarius A star. With the mass of 4 million suns, its gravity whips entire stars around in frantic, high-speed orbits. We are not in the chaotic, crowded galactic center. Our solar system is located about 2/3 of the way out from the center, on a smaller partial arm called the Orion Cygnus arm. This quiet neighborhood is part of the galactic habitable zone, far from the core's intense radiation. It takes our sun about 230 million years to complete just one circuit. The last time our solar system was in this part of the galaxy, dinosaurs were just beginning to roam the Earth. As it orbits, our solar system also bobs gently up and down through the galactic plane. Our tour of the Milky Way is complete. Our ship of the imagination travels beyond our stellar city, into the vast dark emptiness between galaxies. Our home shrinks behind us, becoming just one more point of light in the cosmic dark. The Milky Way is not alone. It is part of a small cluster called the Local Group, a gravitationally bound family of over 80 galaxies. Our closest large neighbor, and the group's largest member, is the magnificent Andromeda Galaxy. Andromeda and the Milky Way are on a collision course, drawn together by gravity. In about 4.5 billion years, they will begin to merge. It's not a destructive crash, but a slow gravitational dance that will eventually form one large elliptical galaxy. Let's accelerate our ship of the imagination. As we look out into the universe, we see that galaxies are not scattered randomly. They are clustered together into groups and superclusters. Our own local group is part of the Laniakea supercluster, a colossal structure containing 100,000 galaxies. These superclusters are linked together by long, delicate filaments of galaxies, built on an invisible scaffold of dark matter. It is a cosmic web, the largest known structure in the universe. Between these glowing strands lie the great cosmic voids, vast regions of near-total emptiness. As we fly through these superclusters, we witness a stunning diversity of galactic forms. We see majestic spiral galaxies, their arms filled with young blue stars. We see giant elliptical galaxies, reddish spheres of older stars. Then there are the irregular galaxies, chaotic in form, often the result of galactic collisions. Looking at distant galaxies means we are seeing them as they were in the distant past. We can see galaxies that are over 13 billion light-years away. Their light has traveled since the universe was in its infancy. We are witnessing the cosmic dawn, seeing the first galaxies flicker into existence. Our 15-minute journey is coming to an end. It is time to return. Let's bring our ship back home. We find our quiet suburban street, a familiar medium-sized yellow star. The swirling blue and white marble of Earth comes back into view. Looking back at Earth from the depths of space gives us the cosmic perspective. It is a viewpoint that inspires profound humility, a powerful reminder of our shared existence. The very stardust, forged in the fiery hearts of dying stars, has come together to form living beings who can look up, wonder, and understand. We are the universe's way of knowing itself. Our journey shows us that we are deeply and inextricably connected to the cosmos. The laws of physics that govern the most distant galaxies are the same laws that operate within our own bodies. As we settle back into our lives, our journey through space may be over, but the journey of discovery has just begun. Next time you look up at the night sky, perhaps you'll see it differently. The sky is a time machine and a map, so keep looking up, keep asking questions, nurture your wonder. The universe is the grandest theater, and its epic story is still being written. We are here now, on this beautiful world, privileged to be able to appreciate the show. The cosmos awaits. The endless journey continues, a journey for all of us, together.